All right, we're on here for some exponential and logarithmic models word problems. Okay, for problem 13, you've got to, you're given that you have $10,000 to start with and you have 3.5% interest rate. All right, what you want to do here is you want to calculate, first question is how many years for it to double? Well, double would be $20,000, so we're going to use the PERT formula. Amount of money is equal to P times the E raised to the RT. R is the rate, T is the time. So $20,000 is equal to $10,000 times E to the 0.035 times T. All right, now we're going to divide both sides by 10,000, but that's just going to give us 2 over here. So 2 is equal to E to the 0.035 T. All right, we're going to take the natural log of both sides. And that's going to get that 0.035 T out of the power position. So the natural log of 2 is 0.69315. And then this side is just going to give us the power. All right, and now we're just dividing both sides by 0.035. And this will be the time it'll take for it to double, 19.8 years to double. And then the second part of question 13 is how much money will be in this account after 10 years. This time we're just going to use the PRT right as it is. So amount is equal to $10,000. Did I put in too many zeros? I think I might have. No, I guess that's enough. Times E to the 0.035 times 10. So just type this all into your calculator, 10,000 times E to the 0.35 power, and it'll just spit out your answer. $14,190.68 after 10 years. So the first problem we had to do a little bit with logarithms. This one we don't have to do anything with logarithms. All right, next one, 15. Kind of a similar problem. In 15, you have $7,500. And you know that it doubles in 21 years. So they don't give you a rate in this one. Okay? But doubling, you know that doubling would be $15,000. We're going to figure out the rate first. And $7,500 times E to the 21, whoops, that should be a 1, not a T, 21R, because you're missing the rate. But you know you want to double. Well, we're going to do a division here. And just like in the previous problem, when we do the division, we're going to get 2 is equal to E to the 21R power. We're going to natural log both sides. And then this is going to be that 0.69315 again. And this is going to be the 21R. And we're going to divide both sides by 21. And the rate this time is it'll give you 0.033, but we'll have to move the decimal over 2 places. That's 3.3%. The other thing that 15 was missing is how much money in 10 years. So this one's just going to be, we're just going to do the A equals P ERT formula. So $7,500 E, and now we know 0.033 times 10 years. So this one you can just type into your calculator, 7,500 times E to the 0.33 power. So if you type that all in, out comes your calculator, $10,432.26. So again, didn't have to use logarithms on this side to get the 10 years, but we did have to use logarithms to get the rate. So anytime you're trying to get some information that's in the power position, you're going to have to use logarithms to solve that. In this case, natural logs. All right, next question. 17, it's out of the same category. In this one, they tell you have $5,000 to start with. So your P, or your A equals, is it A equals or P equals? I can't remember. Yeah, this should be A equals. Yeah, this is your A value. Or sorry, this is your P value, your initial amount. And they tell you that in 10 years, you have this much money, $5,665.74. So your first job is going to be to work backwards out of this to figure out what the rate was for those 10 years. So that 5,665.74 goes on the left, the 5,000 goes on the right. You got the E, and then you know this is for 10 years, so you got 10 times the rate, so you're missing the rate. So we're divide by 5,000. Not as nice as the other ones, because those other ones you were doubling it, and this division just gave you 2. This division gives you 1.133 is equal to e to the 10r power. And then you take the natural log of both sides. Take the natural log of this side. This side just works out to be 10r. And really, you could do this all on your calculator, but the decimal is 0.12487. I'm like writing out a lot of decimal places. And that's what you have to divide by 10. So the rate was 0.012, we're just rounded to 0.0125. So it's a 1.25% rate. All right. And then the last question on this one is how long before it, the second question was how long for it to double. Okay, how long for it to double. So this one we're gonna have to do logarithms on both sides here, because we want to double it. We want it to turn into $10,000, which is equal to $5,000 times e to the 0.0125, because now we don't know the t. We don't know the time it's going to take. But you'll divide by 5,000, so you'll get 2 again. E to the 0.0125t. Then you'll natural log both sides. And the natural log of 2, that same 0.69135, is equal to 0.0125t. Oops, that's a t right there. So divide by 0.0125. Sorry for my sloppy handwriting. And the time to double is about 55.5 years. All right. Okay, that's 17. 19 comes from the same category. In 19, the first question you have to figure out is what was the initial investment, because in this one they tell you that the amount of money after 10 years is $100,000. So you got to work backwards from that to get to how much money there was initially. Okay, so if it's $100,000, that was some money you started with. E, they tell you the rate's 4.5%, so it's 0.045 times 10. So that $100,000 is there after 10 years. So, well, basically on this one, this $100,000 is equal to PE to the 0.45. This E to the 0.45 is a value that your calculator has. So we can divide both sides by E to the 0.45. This you can type into your calculator. And it'll tell you $63,762.82. That was the initial investment. All right, now that we have the initial investment, now the second question here is how long for that to double? Well, we could double this 63,000 number, but that's just messy. All the other doubling ones we set them up, and they had, the 0.045t. But when we do the first division, we always get 2 over here, because that's what we want it to double. So 2 is equal to e to the 0.045t. And then you're going to natural log that 2 again. Natural log this side. Oops, 45t. And when we natural log 2, we'll get that 0.69315 again. Oops, 315 equals, 0.045t. And then we'll divide by 0.045. Divide by 0.045. And when you type that in, it works out to be 15.4 years to double. So we didn't mess around with multiplying this by 2 because it would have been a mess. But we know when you're checking for doubling, that's a 2 right there. All right, that's enough of the money questions. Now we're talking about some half-life questions. So for the half-life questions, we are going to use this formula. Y equals A times e to the negative bx. Okay, that's because it's exponential decay. So this is both for 25 and for 27. So for 25, it tells you have 10 grams of something, and you know what the half-life is. It's 1,599 years. So half of 10 is 5. We got to figure out the rate of decay, the yearly rate of decay. We know when it gets to become half of itself, but we got to figure out what the amount of decay is per year, percentage-wise. So E, now we'll put the year in. Oops, and then the x. The x is kind of the rate of decay. Ignore that little, put that back in there. All right, so we're going to divide just like we did back in the other ones. We're going to divide by 10, but there's a 0.5. That's what you'll always get when you're doing half-life, is a 0.5 right there. Excuse me, 0.5 is equal to e to the negative 1599x. And we're going to natural log both sides. Natural log e, because we got to get something out of a power. So, and here's what I like to do. I don't even like to type this at all or into a decimal yet. So this side is going to be negative, whoops, sorry about the writing there. This side's going to be negative 1599x is equal to the natural log of 0.5. And we can just divide that by negative 1599. Divide that by negative 1599. And you can type all this, sorry about that timer. You can type all this into your calculator. Natural log of 0.5, close the parentheses, divided by negative 1599. You get a scientific notation number, and you get, it's like times 10 to the negative 4, but what it works out to be is 0.000433. So that's the yearly decay rate of this whatever element it is. I don't even look what element it was. And now you got to figure out how much is there after 1,000 years. So the amount after 1,000 years is equal to the starting amount times e to the 1,000, sorry, times 0.000433. So this is your time and this is your rate. Okay. Now you could type this all into a calculator here pretty quick. You could do this multiplication before you do the whole thing in your calculator, but that 1,000 is just going to move the decimal over 3 places. So this is what you have to type in your calculator: 10 times e raised to the 0.433 power. If you need help with your calculator, let me know. This kicks out 6.49, and that's how many grams it would have after 1,000 years. And you're like, well, that's not even half. Well, yeah, that's because 1,000 years, the half-life was 1,599 years, so that's why there's more than half left. All right, so you got to get the rate first. That's what we did over on the left side. Then you have to use that rate to calculate for a different year amount. 27 is going to be real similar. 27 is going to be real similar. Let's rock on that one and be done. So 27, you only have 3 grams to start with, and you want to figure out the rate for it's the half-life is 5,700 years. 3 grams, 5,700 years for the half-life. So half of 3 is 1.5, and then e to the negative 5,700 x. You could call it x, you could call it r. All right, we're going to divide by 3. You're going to get 0.5 e to the negative 5,700 x power. Then we're going to natural log both sides. And then we're going to get negative 5,700x over here. It's equal to the natural log of 0.5. Divide by negative 5,700. Going to get a really tiny decimal again. X is equal to, works out to be, 1.22 times 10 to the negative 4, which is 0.000122. All right. Now we're going to go over here and figure out how much is in there after 1,000 years. So 3 times e to the negative 1,000 times 0.000122. All right, so 3 times e, whoops, what just happened there? 3 times e to the negative, got to keep a negative there. Did I forget a negative on the other one? 0.122. So 3 times e raised to the negative 0.122. That's what you'll type in your calculator, and it'll kick out that you have 2.66 grams. So that's, you still have quite a bit left after 1,000 years. All right, 2.66 grams. So did I forget the negative in this one? Yeah, sorry, this should be a negative here. Back in problem 25.